Okay, now look at this question, yeah? A pulley is mounted on a frictionless pulley and the pulley is attached to a higher end of the inclined plane as shown in the figure. A massless cord is wrapped around the pulley while the other end is tied to a 1 kilogram object. Okay, the pulley has a radius of 20 cm, okay, and a moment of inertia of 0.4 kilogram meter square. The angle of the surface is 37 degree and the coefficient of kinetic friction is 0.2. Okay, the object is released from rest. Okay, the pulley starts to rotate as the object moves and the coil unwinds. Determine the acceleration of the object, okay, and the tension in the cord. Okay, all right. So we want to find acceleration of this object, okay, acceleration of this object and the tension in the cord in the string. Okay, so okay, first of all we draw the free body diagram. We're drawn already. This should be the free body diagram, yeah. Okay, the object, the mass, we regard as a point mass. This is a point mass, and this pulley is a rigid body. Okay, it's a rigid body. This mass is a point mass. Okay, all the forces start from the point. Yeah, all the forces start from point, but the pulley is a body. It does not start from the center. It starts from the force you draw at the side. Yeah. Okay, so these are the forces that acting on the mass. Okay, we have the weight, normal force, the tension in the string, the friction, because he did mention this surface has coefficient of kinetic friction. This is the mu only. This is the mu, not the friction. Friction, you have to find out. Friction Fk, you use mu Kn. Fk equal to mu Kn. This is just the mu K. This is just the mu K. It's not. It is not the friction yet. It's not the friction. It's just the mu. Okay. So you have to use mu Kn to find the Fk. Okay, so this pulley rotate, okay, because of the tangential force. Okay, this is the tension. This one got linear acceleration and this one got angular acceleration. And then we use this one is rotational dynamic. Okay, so we need to use the Newton's second law to do it. Okay, Newton's second law. Look here. So for the mass, we use total F equal to ma. We use total F equal to ma, Newton's second law. And for the pulley, we use total torque equal to I alpha to do it. Okay, total torque equal to I alpha. And then the positive negative sign. So you see this like this mg, you need to resolve. You need to resolve mg into two components. To parallel component and perpendicular component. You need to resolve into x and y component before we can proceed. Okay. The other force, I think no need to resolve. Okay, and then the direction, you need to which forces are positive, which forces are negative. Follow this principle. Follow direction of acceleration is positive. Opposite the acceleration is negative. Okay, and then about the rotational motion, follow the angular acceleration torque. The torque which is follow angular acceleration is positive torque. Any torque which is opposite the angular acceleration is negative torque. And how to relate between A and alpha? How to relate between A and alpha? We use A equal to R alpha. A equal to R alpha. Okay. A equal to R alpha. So you can proceed with these questions. All right. Important thing is to draw your free body diagram correctly. That's all for these questions.